So the next thing we're going to talk about are events and their complements. So the complement of an event is the collection of all outcomes that are not in the event itself. So if A is the original event, then A prime, we read this A prime, is the complement of the event. So because one or the other always happens, when we add up the probability of A and A prime, it always equals 1, because the probability of one or the other thing happening is always 1. So we can solve for the probability of a complement by subtracting the probability of the event from both sides. And so we get this formula that says the probability of a complement is equal to 1 minus the probability of the event, assuming we know the probability of the event. For example, if the probability of winning a game is A, or excuse me, the probability of winning a game is P of A equals 1/4, what is the probability of losing the game? So in this case, we're going to ignore the potential for a draw. Either you win or you lose. So the probability of losing, so PA prime, is equal to 1 minus 1/4, which is equal to 3/4. I'm not sure I'd want to particularly play this game if the probability of losing is so high, but people do all the time. It's why Vegas is a profitable place. So this is the main idea of complements. We'll do a couple more examples just to make sure we're familiar with the idea, and then we'll wrap up the lesson. So some more examples on complements. So the probability it will rain is 0.25. What's the probability that it will not rain? So we have the probability of not rain is equal to 1 minus 0.25. So the probability of it not raining is 0.75. How about a question about gender? The probability that a baby will be a boy is 51.2%. What's the probability of a girl? So probability of girl is 1, but this is a percent. So because it's a percent, that was not highlighting, because this is a percent, rather than 1, I need to write it as a percent. So I'm going to have 100% minus 51.2%. And this equals about, I think, 48.8%. Of course, every year I say I'm going to change this question because gender is not specifically male or female. There are people who are born who are intersex, and there are people who, although they might be assigned one sex at birth, they identify as a different gender. So even though the probability that someone will have an XX or XY chromosome combination is more or less equal to this, they're not actually complements because there are alternatives. For the sake of example, however, it does illustrate nicely how we would change our setup to accommodate for percentages. So that's it for this video on complements. Like I said, it's going to be short. At least I think I said that. If I didn't, I thought it. In any case, it's a short video. Our next video will be additional examples of complements and probability probability with some different scenarios. So I hope you'll watch it. Otherwise, this is it for new content in this lesson.